So since we're dealing with a z-distribution, our data looks like this. It has this nice symmetric shape to it. This is one of the most important characteristics about the z-distribution, or normal distribution as it's sometimes called. So we plot the mean right in the middle of the graph, the 14%. And because it's symmetric, we know that 50% of the data falls on this side of the 14% and 50% of the data falls to this side. So we know right away the probability of observing a return greater than 14% is 50%, and we have a 50% probability of observing a return less than 14%. That's something we know right away just based on the symmetry of the normal distribution. So we want to find the probability of observing a return between 16% and 20%. So let's just add those to the x-axis, and those go to the right of the 14% because they're both greater than 14%. It's good to add these to your graph every time you're doing one of these types of questions because it'll help you understand what steps you need to take to find the probability we're interested in once we get to the step where we look up the z-numbers in our z-tables. And so we're interested in this probability right here. The numbers on the x-axis, again, represent the actual returns, the 16% and the 20%. The area under the curve represents the probability of observing a rate of return in between those two numbers in that interval. And so that's the probability we're after. So first, we need the z-numbers for these two returns. We need to convert the returns to some standardized number that we can look up in our tables. We know the mean of this distribution is 14%. We're told that in the question. And the standard deviation is 4.8%. So again, we're converting the 16% and the 20% to standardized numbers, to z-numbers, and we need to use this formula. The z-number is just equal to the actual return. So in this case, the 16%, we're going to start with the 16%, minus mu, which is just the mean, divided by sigma, the standard deviation. And again, the mean and the standard deviation are given to us in the problem. So first, let's find the z-number for the 16% return, this lower bound on the interval that we're trying to estimate. So we plug in the 16% for the r hat, and we subtract the mean, the 14%, and divide the difference by the 4.8%, the standard deviation. That gives us a z-number of 0.42. So we'll just put that on the table. We want to do the same thing for the 20%. So the z-number that corresponds to the 20%, the only thing that changes is r hat, the actual value that we expect. And so we plug in the 20%, subtract the mean of 14%, and divide by the standard deviation of 4.8%. And we get a z-number of 1.25. And so now the problem becomes, what's the probability of observing some number in between a z-number of 0.42 and 1.25? So it's the same question. We're still looking for this area, but now we've changed the problem into a standard one that we can actually use these z-tables to look up. And so we can look at the z-tables, the z-numbers in our z-table, but because the way it's formatted, our z-table actually tells us the amount of data that lies between the mean and a given z-number. So this is maybe a different format than what you're used to. In your other statistics classes, you might have seen something that tells you the probability that lies in what's called the upper tail. Well, this one is different. If we look up a z-number, so say we look up 0.42, our z-table is going to tell us the probability of observing a return between the mean and up to that point. So it would tell us this area right here. Similarly, once we look up 1.25, it's going to tell us the distance between the mean, the area under the curve, from here all the way up to the 1.25. So that's important to understand because it's going to change your answer. You need to make sure that when you look up a z-number, that you know that's the probability that you're getting. So let's look up the probability of observing a z-number of 0.42 in our table. What do we get? Well, when we look it up, we get a probability of 16.28%. And again, that's going to be this red area right here, the total area under the curve from the mean up to that z-number. We do the same thing. We look it up for the z-number of 1.25, and we find the probability is 39.44%. That's going to be this whole blue area, all the way from the 14% up to the 1.25, so that whole area right there. Again, we're interested in the probability that return will be between the two z-numbers. So now, since we have the two areas, all we need to do is subtract. So we take the 39.44%, this whole area right here, we subtract just the 16.28, which we found was right here, and we're left with a 23.16%, which is this green area right here, and this is what we wanted. This is the answer to the question.